This one's another powerful supervised machine learning tool, linear regression, and in today's video, we're going to use linear regression to predict housing prices. Let's dive in. In reality, many factors influence a house's price, like location, number of bedrooms, the age of the property. But to keep things simple, we'll focus on just one key factor, which is square footage. So here are the first five rows of the data, and this is what a scatter plot looks like. Housing price in dollars on the y-axis and square footage on the x-axis, and the blue dots represent our data points. So when you closely look at these points, there's a clear pattern. As the square footage increases, the price also increases. And this suggests there is a relation between price and square footage, and our goal is to capture that relationship mathematically. So let's go ahead and represent this pattern using the simplest shape, which is a straight line. This line allows us to make predictions. For instance, if a house has 900 square feet, the line projects the price to be around $225,000. So after all this, let's go back to our high school math and recall that every straight line, no matter its position or tilt, can be described by a simple equation, which is y equals mx plus c. And in our case, y equals mx plus c becomes price equals m times square footage plus c. Let's break it down. Y is what we're trying to predict, which is the housing price. X is the factor that affects Y, which is the square footage. M is the slope. It tells how much the price changes for every 1 square foot increase. And C is the intercept. So C is the point where the line crosses the y-axis. This represents the base cost when the square footage is zero, which could be the cost for like land or location. So it's like a fixed cost. Suppose if this straight line is modeled by this equation, we will roughly get the following. And this means that for every 1 square foot increase, the price goes up by $200. And if the square footage is zero, there is a baseline price of $20,000, which represents other fixed costs. And if you can see, the model line does not perfectly fit all the data points. And even if the straight line does not pass through all the data points, we can still find a line that best fits the data. And this is the essence of linear regression, which is to approximate the pattern to make the right predictions. So whatever we've discussed so far is simple linear regression because we are just using one feature to predict the price. But in the real world, multiple factors influence housing prices, and in that case, simple linear regression becomes multiple linear regression. For example, in our housing price prediction, we can consider square footage, we can consider number of bedrooms, age of the house, and similarly we'll have M1, M2, M3 as the measure of the influence of each feature on the price. So what's the big idea? Linear regression helps us find a straight line relationship between two variables, in our case square footage and housing price, and no matter how scattered the data is, we can model it using the equation y equals mx plus c. And this allows us to predict future outcomes and understand relationships between variables. Here are some common applications, and I will see you in the next video.